Hello students, welcome to all of you in my YouTube channel. I am Dr. Himanshu Sarkar. In my last classes, I have discussed different sections of the electrostatics. That is what is the electric field intensity, what is Coulomb's law, then the dipole moment, electric field intensity due to the dipole in end-on and broadside position, etc. And also in my last class I have discussed the continuous electric field intensity due to the continuous charge distribution. That is, if the charge resides on a hole of the ring and also if the charge resides on a rod. That I have also discussed. Now I will discuss what is the torque acting on a dipole placed in an electric field. These all are important for class 12 physics, for ISC, for CBSE, etc. and other boards, and for the JEE and NEET. Before that, I request to all of you to subscribe my channel so that all of you can view my channel videos. Okay. Now, today I will discuss in electrostatics, that is torque acting on a dipole placed in an electric field. My topic is that torque acting on a dipole placed in an electric field. You know what is the meaning of torque? You know, suppose two parallel forces function different points in the opposite direction. If the distance between the two forces are, so the couple is function and the torque of this couple is equal to F into R. All you know. These two parallel forces not acting at the same point, different points. This is the couple. Torque of this couple is equal to what? This force into perpendicular distance. All you know. In dipole, already in lots of classes I have taken regarding the dipole. Dipole means you know equal and opposite charges separated by some distance is called dipole. So this is suppose the electric field E. This is the electric field E. E is here what? Electric field intensity. This is a dipole. Dipole means this charge plus Q, this charge minus Q. Let this angle of this dipole axis electric field is what? Theta. Angle between the electric field and the dipole axis is theta. And I choose length of the dipole, that is what? 12. 12 is the length of the dipole, is electric field intensity. Okay. So now, what forces function? You know this is plus Q charge. So this force is equal to what? Q into E. Because electric intensity is this direction, so force in this direction, and this is minus Q. So what is the force? That force is equal to Q into E. Because force is a vector quantity. You know this force and this force, these two parallel forces. So what is the torque? Torque means drop. Torque means drop this line perpendicular this line. If this angle theta, this length you know 12, that is the dipole length. So this distance is equal to what? 12 sin theta. Clear? So this force QE and this force QE in the opposite direction parallelly, and the distance between the two force lines is what? Perpendicular distance 12 sin theta. So What is the torque? Torque, torque, that is tau, that is equal to what? Force, that is QE into 12 sin theta. You know, you can write down this form 2QL E sin theta. You know 2QL means what? Dipole moment. Length of the dipole is what? 12. Charge plus Q or minus Q. So if I write down P is equal to what? 2QL, that is called what? Dipole moment. So torque is equal to what? So torque is equal to, so this is the P dipole moment. So torque is equal to 2QL into E sin theta. That is what 2QL is what? P. So PE sin theta. So torque in the vector form, that is what? P cross E. It is a cross product. So this is a formula of the torque, and this formula is very important formula for all of your class 12 syllabus, for the ISC exam, for the CBSE exam, and also for the competitive exam like JEE, NEET, like that. So this formula is very much important formula. So what is the torque formula? Torque is equal to P cross E. That is the torque formula. Okay. So I think all of you clear regarding this. One thing, if you have any doubt regarding this matter, I have given the WhatsApp number in my description box. You can take it and you inform me via the WhatsApp number. Thank you. I am stopping my class here, and in my next class I will discuss the dipole oscillation.